In this class, we're going to go over some calculation on the basic machine that we have learned in our previous class. I told you that all these basic machines, they have three properties in common. The first characteristic is that they all have mechanical advantage. You understand? Mechanical advantage. Then the second one is the velocity ratio. You understand? The velocity ratio. And the third is efficiency. Okay, these are the three properties that is common to the basic machine that we discussed in our previous class. I explained all these basic machine in our previous class, but we didn't treat any calculation. In this class, we're going to be focusing on calculation, you understand, under each basic machine. Do you understand? Okay, the mechanical advantage is given by this formula. Mechanical advantage equals to load over effort. You understand? Please pay attention, okay? Mechanical advantage is equals to load over effort. Now, the formula for velocity ratio is given by distance moved by the load, distance moved by the effort all over distance moved by the load. You understand? Please pay attention. Do you understand? Each basic machine has calculation. Are you paying attention? With respect to the properties that is common to all of them. This is the properties. This is the property that is common to, if not all, almost all of them. We have the mechanical advantage, the velocity ratio, and the efficiency. Now, the mechanical advantage is given by this formula, load over effort. You understand? Now, with respect to the first basic machine that we're going to discuss, that is lever. You understand? Lever. So, please, if you missed the first class, if you missed the previous class, you can check the description of this video, watch those classes so that you won't be lost as touching what we're going to be discussing in this class. Okay, let's start with the first question. Let the effort E acting as a force at A be 250 Newton to lift a load of mass 300 kilogram. When the distance of the load from the fulcrum is 2.5 meter and the distance of the effort from the fulcrum is 6.3 meter, find the mechanical advantage and the velocity ratio of the system. Okay, now let's start by for the sake of clarity, you understand, I'm going to draw the diagram. Okay, I'm going to draw the diagram so that you can understand. We are given that the effort E acting as a force at AB 250 Newton. Effort E, that's the first parameter. Effort equals to what? 250 Newton. Okay. Now let's proceed. And we are given that the load of a mass of 300 kilogram. The load in kilogram is equals to what? 300 kilogram. Do you understand? Okay. Now, the distance of the load from the fulcrum is 2.5 meter. Distance of the load. The distance of the load from the fulcrum equals to what? 2.5 meter. I explained that pivot is also known as the fulcrum. You understand? Okay. And the distance of the effort from the fulcrum is 6.3 meter. Distance of the effort from the fulcrum is 6.3 meter. Now we are asked to calculate the mechanical advantage and the velocity ratio. Now, I'm going to give you a formula. You understand? I'm going to give you some important formula that will enhance and that will enable us to calculate this. But before that, let us try to draw this. Let us put it in the diagram. You understand? Let us put this in the diagram. This is how a lever look like? In our previous class, we discussed the shape. You understand? Now, please pay attention. This is how a lever look like. On this lever, we have the load part and the effort part. Now, we are given that the effort E acting as a force at A is 250 newtons. Let us call this place A. Let us call this side A, and let us call this BE. Let us call this side B. You understand? The effort acting on this on the A side is what? 250 newton. You understand? And the load here is what? 300 kilogram. Please, do you understand? I'm just trying to draw the diagram. Okay. Now, when the distance of the load from the fulcrum is 2.5 meter. So let us shift this fulcrum to this side, because if this is 2.5 meter, that is the distance from this point to this point, from the load point. From the load point, that is 2.5 meter. And the distance from this point to this point is 6.3 meter. 6.3 meter. You understand? So you can see now I've already interpreted the question into diagram. You understand? The distance from this is the effort side, this is the load side. You understand? So this is the effort arm and this is the load arm. You understand? So the effort that is applied in an attempt to lift up this load is what? 250 newton. And the load that is to be lifted, the mass is what? 300 kilogram. You understand? So we can easily determine the mechanical advantage. The mechanical advantage is given by load over effort. You understand? Now the load is what? 300 kilogram and the effort is what? 250 newton. But we cannot use this load. We have to convert it to newton because it is in kilogram now. Are you paying attention? You have to change the load from kilogram to newton. That is it. The mass of the load is what? 300 kilogram. We have to change it to newton. We cannot use 300 kilogram directly. Okay? So to change the load from kilogram to newton, you have to multiply it by 10. You understand? So the load in newton will be what? 300 multiplied by 10. That is what? 3,000 newton. You understand? So mechanical advantage equals to load over effort. You understand? Load over effort. Load is 3,000 newton. So I'm going to have 3,000 newton all over 250 newton. You understand? So the mechanical advantage here is what? 3,000 newton divided by 250 newton. The load is the mechanical advantage is 12. You understand? The mechanical advantage is 12. Now there is no unit because this newton will have cancelled this newton. Okay. Now this is the first answer to the first question. The second question is velocity ratio. Velocity ratio, please pay attention. This one is very important. You know, when I'm giving you the formula, I intentionally don't give the formula for velocity ratio because with respect to each basic machine, the formula to calculate their velocity ratio might be different. You understand? It's even different. Let me put it like that. So velocity ratio with respect to lever, you know, we are dealing with lever now. That is the first basic machine. Velocity ratio is given by this formula: the distance moved by effort all over the distance moved by the load. Do you understand? The distance moved by the effort all over the distance moved by the load. Now, the distance moved by the effort, distance by effort, moved by effort all over the distance moved by load. Now, this is the distance moved by the effort. The distance moved by the effort is the distance from the fulcrum to the extreme end of the effort. You understand? This is the distance moved by the effort. That is velocity ratio for lever now is what? 6.3 meter all over 2.5 meter. 2.5 meter. And if you divide 6.3 meter by 2.5 meter, you're going to have 2.52. You understand? 2.52. 2.52. Now, the mechanical advantage is equals to 12 and the velocity ratio is what? 2.52. Now, let's say you are asked to determine the efficiency. Efficiency is given by this formula: mechanical advantage all over velocity ratio multiplied by 100. You understand? though we are not asked to determine the efficiency, but in some cases you might be asked to determine the efficiency. Now, having gotten your mechanical advantage as 12 and the velocity ratio as 2.52, you can easily determine the efficiency. You just have to take the division of 12 and 2.52, multiply it by 100. That is the efficiency. I pay attention. So take that as the first calculation, you understand, under labor. Now let's proceed to the second basic machine, which is we are given this pulley system. We are asked to determine the velocity ratio. The velocity ratio in the pulley system is the numbers of pulleys that the pulley system contains. You understand? The velocity ratio of a pulley system is the numbers of pulley that the pulley system contains. You understand? We have 4 pulleys. 2 pulleys out of these 4 pulleys are fixed pulleys. You understand? And this is the other 2 are movable pulley. You understand? This pulley and this pulley are fixed, while this and this are what? Movable. You understand? Now the total numbers of pulleys give the velocity ratio. Hence, in this diagram, the velocity ratio is 1, 2, 3, 4. That is 4. Okay, that is the velocity ratio. Okay, let's move to another basic machine. The third basic machine that we're going to discuss is the wheel and axle. You understand? To watch the next class, kindly check the description of this video. You are going to see a link there. Click on that link, or you should check the playlist on this channel. Okay, see you in the next class.